Welcome everyone. Hi, good to see you all. Well, good to have you on my webinar, I should say. I know we can't see and talk to each other, but you can see me, so welcome. Thank you so much for tuning in today. A lot of longtime friends I see have joined the webinar so far, so thank you for attending today. All right, so we're about ready to get underway here. Just give it a few more minutes, well, seconds really. We'll get started right at 11 o'clock, at least by the computer time in Florida here. So I am Joshua France, as many of you know, and I'm speaking to you today live from Winter Garden, Florida at the RIEGL USA headquarters. All right, so we're right at 11 a.m. I'm sure some folks will trickle on in, but I'm going to stop paying attention to how many people are logging on and focus on presenting today. So welcome. I am live and in person. So good morning and welcome to our webinar series where we report on all the latest and greatest news and updates out of our office in Austria, who just came off a great week at INTERGEO in Berlin, Germany. I personally was not there. I was back here in the States managing the stateside operations during that time, but I still have all the great news and updates. But we're going to take a little bit different of a tack today and talk about the value and efficiency. One of my favorite quotes growing up was, efficiency is lazy, intelligent, or excuse me. Wow, I really messed that up. So one of my favorite quotes is efficiency is intelligence, laziness. So there's a lot of value to be found in efficiency. So with that, let's get underway. I'm going to stop sharing my webcam, so if I move around too much, it doesn't distract you from my amazing presentation. All right, so efficiency. So what makes a system efficient, especially for mobile mapping? What is it supposed to do that would make it really efficient and effective for our daily operations? Well, if we could drive as fast as we wanted, that certainly would help. However, there are other considerations from a safety factor to consider, so we have to be careful of that. Real-time data, well, having the data post-processed and analyzed and even extracted, all while collecting it would be super wonderful. I'm sure you'd all agree, especially if it was already aligned with GPS control to itself. All of that stuff would make it very accurate and would provide instant feature extraction, of course, and also upload it right to the final customer so they can already review it immediately without having to wait on anyone. Well, that's a bit futuristic. So obviously our perfect future system would drive itself, collect the data, process it, and extract everything without any errors. And on an upside, it would also upload it to a server and bring you back some lunch. Perfect world. So what would that look like according to our AI image generators? Well, as you can see here are two examples of AI generated car. If you just prompt an image generator with a self-driving car collecting geospatial data, you will get cars that look surprisingly similar to Waymo taxis, which can't be too much of a surprise since there's a lot of pictures of that surface circling the internet. But clearly from our application standpoint, we would have to add some other keywords to this phrase to help it find that you need to have the sensors maybe looking out back for road surface scanning. Need to have some additional cameras pointing in other directions to collect different features, things like that. But most part, you know, our AI tools are getting pretty good at delivering what we ask it to deliver to us. So we keep talking about uploading automatically, and I know many of you have these beautiful piles of hard drives somewhere in your office from the time before cloud computing was a thing or cloud storage was a thing, or you didn't have enough IT infrastructure to support upload directly to a server. But as we all know, the transfer speed can really slow down a process. So moving data around is really one of the most costly endeavors of the entire operation. So often you say, okay, you know, collecting the data, buying the system, those are all costs, but moving the data around and converting things to different formats take up a considerable amount of time as well, as you know. So let's take a look at the state of the art in 2023. So where are we with our futuristic society? Are we there yet? Well, we know that the autopilot function exists on many types of vehicles, whether it's a Tesla car that can drive or a GM Super Cruise enabled vehicle. They can take the wheel and drive through many areas of the country, not our daily commute routines from our house to our offices perhaps, but portions of it for sure. AI is used to process data quite often. Even RIEGL has implemented scripting that automatically runs, which is a form of automation. And of course, when we talk about the term AI, we're really talking about, the overarching technology of artificial intelligence, and machine learning is one of those techniques. And machine learning is typically what folks in the geospatial industry are using to help develop those AI routines. So we know that AI can be used in machine learning to extract targets from feature extraction. Topodot has recently rolled out with features in their software to do AI-assisted feature extraction. So has Solved and many others, Parasolid as well. And so everyone's working towards this process. There's still some QA/QC that has to be done to ensure the accuracy meets what our teams are doing, but it's going to get better and get closer to that point. But it's probably not fully automated with 100% confidence yet. So uploading data. So everyone wants to upload data to the cloud. But if you look at the actual network speeds, you can see that we have some challenges still here. We're still pretty slow uploading. That's a long time to wait to upload photos. Just saying. You can still download to a PC or to transfer it to another hard drive at a very fast rate by comparison. So where can we pick up efficiency? Where can we gain? Obviously, we're not going to launch our own satellite brand that provides even faster data rates. We don't have a get out of speeding ticket cards to pass out to our users so they can drive even faster on highways. That's not the approach at all. We have some other approaches that are very effective. So we can improve acquisition tools. So what would that look like? Well, we'd focus mainly on being able to help you decrease the need for recollects, whether that's from the air or the ground. Knowing what you've collected and that it's high quality data is really important to us at RIEGL, and so we're adding tools to help with that. We can help with lower operational costs, and there are some ways we will discuss that. The other way is we can improve the data size, right? So if we collect more data, but it's smaller, then you have lower transfer times. We can improve then, of course, tools for data processing, which enable you to distribute your processing functions across more folks and get more things done in the same amount of time. And also, if we add tools to that process chain that enable you to stay within our software framework. And when you stay within our software framework, you're not transferring data, you're not converting it to different files. All these are very useful in efficiency gains. So let's first talk about acquisition gains. So on the right-hand side, you'll see a video of RIEGL playing as I discussed, and that's a live look at a RIEGL collection done, as you can see, several years ago by the clock in the corner, so not live in that respect. But RIEGL already does many things that enable efficiency. From automatic logging, you can see there's a shapefile of the pink purplish line there, we'll call it, where it's collecting immediately upon acquisition hitting that. So that gives you an immediate way to log data. You can see there's another example of it there. You get visual cues in terms of where you've collected based on your KML files. You can see color instantly. Green is good, yellow is caution, red is error. So a single driver can interface with the collection of this data without too much effort on their side and interference with their main task of driving the car safely. Finally, of course, we have smart data drive space management. And what does that mean? Well, on the VMX and VMQ systems, it will automatically switch from the drive that you start with to a secondary drive when necessary. So if you're driving along, you fill up the first drive, it'll auto switch to the next drive without causing any loss of data, which of course is very important to all of us who go out and collect data. The last thing we want to do is go back and do it again. So acquisition hardware can be improved, and obviously the faster line speed enables you to get better feature definitions at faster speeds. Again, we have the actual speed limit of highways as a limitation there, and of roadways. We want all of our users and operators to be very safe out there and follow the laws and regulations of the area you're in, of course. However, getting better data definition at faster acquisition speeds is key for downstream operations. As you can see, we have a new Minivux HA sensor update this year, in which we've improved the line speed, and we'll talk about that in a second. But definitely an easier setup and operation is the goal of the VMY1 and VMY2 systems, as they are both significantly under 30 pounds per system, which enables single lift operations to be much easier. And then, of course, flexible operations, right? So if we have all these different camera capabilities, we can align our camera needs to the mission, and we're not stuck in one camera, one view angle. And so being able to adjust those enables it to be more scalable for different operations. So what's our big upgrade? Well, we've upgraded the line speed. It's a 17% improvement, and it decreases our line spacing by 1.4 inches. Which is pretty significant when it comes to driving 60 miles per hour, which enables and it also works on near range. So we're closer acquisition capabilities. And generally speaking, with a VMY2, our processing time is rather light because of the data size is not as heavy as our higher speed systems, such as the VMX2HA with the higher line speeds and the number of points. So what else have we done on the acquisition side? Well, now we're making it better, enabling better compatibility. So you can see those are the tube cameras that are famously on the VMX2HA. Now they are appearing on VMY2 systems, and of course VMY1 is potentially an option, but mainly the VMQ, as you can see here from this quick graphic. Okay, that must be later, excuse me. Then we're also adding further cameras, okay? So to add more megapixels. So the Ladybug 6 was announced last year by FLIR, and in short time, we have integrated successfully with the VMX2HA and some VMY2 systems as well here at RIEGL USA. The mechanical mount is similar across the board. So there's just a few changes that need to be made out, mainly concerning the USB 3.0 cable connection between the camera and the CU box has changed slightly on the Ladybug end, but otherwise it's ready to go with some few minor updates. So contact me for more information if you're ready to get a Ladybug 6. We'll make sure it works for you. And then if we take a quick look at that improved details there, you can see that zoomed in on a pano, when exported properly out of RI process, you get very high definition on a sign that's not exactly next to you. So the common capability of our three systems, the VMY2 to the VMX2HA, enables the cameras to be interchanged. So you can buy cameras for your VMX2HA and use them on your VMY2. So you can mix and match cameras across your system fleet, which then makes it a nice cost savings across the board there. So you don't always need to employ the top end on the top end job, so to say. So what else have we done? Well, I'm really excited about this feature upgrade, and I've been excited about it for several years now, as it's been rumored to be in development, and that is our ability to give you real-time JPEG images right on board the 24 megapixel cameras. So what does that mean for you? Well, that means a lot of things. So our 24 megapixels in one camera, not over two, one camera, 24 megapixels. You have a higher frame rate now you're able to achieve, and you're going to decrease the required data you need to store. And then you also don't have to export images from the raw format into JPEGs. So if we add up those efficiencies, how does that work out from a number standpoint? Well, let's take a look at my sample here.
So if you are upgrading from 4 12 megapixel cameras that you currently have your VMX2HA, let's say, you can and to these 4 24 megapixel cameras with the JPEG compression, you can see that the first thing you can do is you can increase the frame rate and you actually decrease the data size that you get. Yes, 10 to 7 feet isn't a major increase, but decrease in trigger size, but it's significant when it comes to pixel size at the center of the image. As you can see there from our results on the 8.5 millimeter lens with 24 megapixel cameras, you're under half a millimeter pixel size at the center of the image. And the real savings is, of course, in time, right? If you can do things faster, what does that enable your down chain processing to do? So now you're saving almost 8 hours every time you do a 4-hour mission. So if we say, okay, so that's 8 hours of someone not necessarily working. Obviously, I know in realistic life operations, you sometimes are transferring data overnight when no one's working. But if there's an error or something like that, then you lose that and have to start on Monday, let's say, in the morning. So if you take the cost of someone not working on that project and just throw it out as a billable hour routine, you can say that after 100 hours of collection, the JPEG cameras really are going to pay for themselves because they're going to save you that type of money from an operational standpoint of not waiting for an operation to occur. So that's it on the hardware side for sufficiency gains, and certainly there is some value there. Let's take a look on the processing side in RIEGL. So as you may know, we have a batch processing mode that you can run with our data processing wizard. We have been doing automated control extraction for several years now using AI powered by machine learning. We have rapid data exports improvements, and now we have additional tools that provide value. So what have we added on the control side? Well, we've improved our algorithm for detecting targets and really widened what kind of targets can be detected. And again, these are just some examples of what we'll be adding to the latest release of RIEGL in the coming weeks. If you don't see one of the targets that your team uses and you'd like to add that, please get in touch with me and get me some data so I can give it to our team so they can add it to our system. We're happy to work with you on that, but we need to have the data to do it. So that's a big help. As you can see, there's lots of applications in which you may not want to put targets on the road or aren't able to simply put them on the road. And so putting them up on a pole or other permanent object is very helpful for proper data collection routines. So where have we added value as well? So we've added a new tool to RIEGL coming soon to help support our pavement cameras. So a couple years ago, we got really excited about our pavement cameras and what they can do. They can provide very high frame rate cameras, up to 24 frames a second, not 24 megapixels, 24 frames a second, which limits motion blur at high speeds of data acquisition. These are downward facing cameras, as you can see here from the picture on the right. And so with RIEGL, you still have to align the data, and then you would export the data to third-party tools. Well, now, let's talk more about the imagery. So one of the advantages is, of course, the narrow trigger distance. However, colorized point cloud looks really good until you get too close. However, going frame by frame of the images is very time consuming. And as you can see, you don't always see everything that you want to see in one picture, so you have to go to the next, to the next, to the next. So it's a bit challenging to analyze. So what we've added is a true orthophoto tool to RIEGL. So this is going to enable us to have a precisely stitched high resolution orthophoto of the pavement surface, as you can see here from this image. And that then enables you to export it, of course, in 10 by 10 meter files as an example here on the right. Then that can be imported to third-party tools. And we hope to have more tools to talk about in the upcoming months and years. So this, of course, comes right into a GIS viewer, for example, and be a place to put it, or other extraction feature. And so let's take a look at the sample more closely. So you can see we had 2 cameras capturing at 5 megapixels each, and they're doing a trigger distance of 1 meter, and they're driving about 70 kilometers an hour. So not super fast, but not too slow either. And we're able to, in the end, capture a resolution of 2 by 2 millimeters. So that's a very high resolution, we think, and very useful for extracting information. Let's take a zoomed in look at this. So as you can see here, we have the zoomed in level of both the point cloud and the orthophoto. And at this zoom level, they look pretty similar, right? You see the colors, you can see details. Some of the cracking already isn't as clear on the point cloud as it is on the orthophoto. So let's zoom in again, and you can see that the cracks aren't really visible in the point cloud, as we know, but they certainly are visible in the orthophoto. So now we have very good information on the cracks, which then can help us better extract them in our feature extraction tools. So we already talked about data movement a little bit earlier, but I want to throw a plug out here to data management, right? So those stacks and stacks of hard drives, while interesting pieces of art, are very challenging to organize, right? And so is having data on servers, especially when people come and go from companies and people change their naming conventions. So why not use RIMAP, which is a free plugin for ArcGIS tools. As you can see here, you can get the RIMAP plugin today from the Esri App Store, I believe is what it's called. Very simple to download, very user-friendly and intuitive to those that are GIS savvy. And it will take the RIEGL projects and catalog everything for you. It'll give you the scan time per record. It will give you the operating time for each of the different types of scanners, and it will give you an overall view of the where the data was collected. So you get a very quick, easy way to display your team's data, not only for internal clients, perhaps also to help advertise what you've done already as a company, but also selling the data workflow internally is very important. So to wrap up by the numbers here. So I take one of my favorite segments from PTI, from ESPN Sports, or ESPN's PTI, by the numbers. All right, here we go. So reliability. BMX is up to 14 years and running of being a constantly used system throughout the industry. Very well respected. 150 lines per second is the new scan rate maximum for the Minivux HA. We can now deliver 240 megapixels of imagery in one pass on the BMX 2HA. That includes one spherical 72 megapixel camera and 7 24 megapixel JPEG cameras. Beat that. Flexibility. You have one camera type supported by 3 different systems. Not too shabby. So, thank you very much for tuning in today. I'd like to point your attention that there are several other webinars for you to cover some of the more news out of RIEGL and INTERGEO. Thursday, we have an ALS webinar that will focus on the 680, the VQ 680, as well as some pod updates for our utility corridors. So make sure you check in on that. And then coming later this month with the release of our recordings will be the update that was delivered last week by our US team on the VUX 180 24 edition and the new RIEGL. And the RIEGL is a RIEGL developed IMU GNSS system. So that's going to be interesting on the Minivux systems going forward. And of course, if you haven't heard enough about the 600i yet, there'll be a TLS webinar that you can listen to and hear all of the great success stories of our latest VZ 600i tripod laser scanner. So I think we have some time for some questions. Here's my contact information in case you don't have it already. So let me jump into the questions here. We've got some hands raised. Okay, thank you for correcting me. It is the Esri Marketplace. So go ahead and add your questions. Be happy to answer them for you. Yes, so the data that I showed on the exported pano imagery is from the Ladybug 6, not from the RIEGL system so far. We're not doing panos with any other camera other than the Ladybug cameras right inside the RIEGL framework. Any more questions? I see there's a hand raise here.
Yeah, so this presentation is going to be distributed afterwards at the end of the month. We typically, once all of the presentations are done, send out an email to everyone that registered, and they get the link to watch them again. Yeah, so there's a great video on RIMAP on our video lab. Also, the manual is pretty simple to go through. And once you download it, if you have some questions after playing around with it, please reach out to me on RIMAP. So another good question is when is the orthophoto going to be released? I don't know that yet, but it will be coming in a new release of RIProcess. And I'm not sure if it's going to be a separate license or not yet. So there's some details still working out, but I think it's going to be a great tool. The 24 megapixel cameras with the JPEG compression are available for initial order. So if you're really interested, please get in contact with your RIEGL sales rep. If you're in North America, that's me. I'd be happy to get you a quote on that so you can get those added to your system soon. Another good question. Yeah, the Ladybug 6 is available for deliveries as soon as you would like them to be. We have a couple in stock at our office here in Florida. So in the US market, we are sending them with the system. However, internationally, that could be different depending on your location. Please look into that. Oh, another good question. The RIMAP plugin, is it compatible with older RIProcess versions, pre-serial licensed? So RIMAP does not need a license, and it works with any of the RPP files, so the RIProcess files. I think they may have to be 2021 or 2022 era, just due to they have to be at least the new version of RIProcess. There was a cutoff date, I want to say in 21. So as long as they're newer than 21, which just might mean you have to open an older project to be able to catalog those. Good question. I thank you all for joining me today. Great attendance, I must say. Thank you all for coming.